And here's the last example using two current carrying conductors, and we're going to find the magnetic force on the two conductors. Remember, it's the same as the charged particles like we did with examples 6 and 7. Now we're just going to look at the current through the conductor. Now when you look at this example, remember the electrons always come out of the negative terminal towards the positive. So the negative terminal is always the smaller. So electrons always come out of the negative. That's the first thing you have to remember. So when we set up the first diagram, we've got our magnetic field in this case going into the page. The current is going from left to right. So when we set up our hand, and by the way, that's not my hand, it's my wife's picture, just in case you're wondering. My fingers are going into the page. My thumb is in the path of the electron flow. So they're going from left to right. So you should see your palm pointing down. So the magnetic force, in this case, would push that conductor down. Fingers in the direction of the magnetic field. Thumb in the direction of the current or velocity of the charged particle. Palm is the direction of the force. Apply that same rule to the example on the right, and again your current is going from bottom to the top, so your thumb is pointing to the top of the page. Your fingers go from north to south, so your magnetic force should now be coming out of the page in this case. Takes lots and lots of practice, which is why I want you to go through the exercise 3.2. You'll get even more practice in the next couple of lessons as we go through when we start doing calculations. But I always like students to take a little bit of time practicing the left-hand rules, getting those down pat first before you start to do the mathematics of the formulas. You'll actually find directions to be the hardest thing to do. The formulas are not that difficult in this unit, but describing the directions based on the scenario you're given always tends to be the most difficult task.